Okay, great. Good morning, good afternoon, and good evening. I'm Diana, and I'm the Global Blockchain Business Council's Head of Research and Sustainability. It is my pleasure today to welcome you to GBBC's Virtual Members Forum on Accelerating the Energy Transition with Powerledger's Public Blockchain. We're a bi-weekly webinar showcasing the innovative work of our members around the world. And today we're joined by Dr. Jemma Green, CEO and Chairman, and Dr. Vivek Bhandari, CTO at Powerledger. GBBC member Powerledger has launched its public blockchain in 2023 and is at the forefront of advancing innovations driven by emerging technologies like blockchain that are shaping the future of energy management and distribution. So briefly, before we begin today, I would like to introduce Jemma and Vivek. Dr. Jemma Green is a visionary leader in the field of sustainable energy innovation. As co-founder and chairman of Powerledger, she has played a pivotal role in reshaping the landscape of energy markets with blockchain-based solutions. Her impressive journey and contributions have solidified her as a prominent figure in the global energy sector. She and her team are dedicated to creating a viable market for renewable energy that empowers consumers. This mission began with her PhD in electricity market disruption, the seed of the idea for Powerledger, and her championing of sustainability and corporate social responsibility while working in finance for banks like JP Morgan. In 2018, Dr. Green won Sir Richard Branson's Extreme Tech Challenge Award, followed by the EY FinTech Entrepreneur of the Year Award. She believes in bringing continuity in transmission and distribution that is less liable to conventional grid failures. Under her leadership, Powerledger is innovating in cutting-edge software solutions to create energy markets that remove the obstacles to 24/7 renewable energy. Dr. Green co-authored a best-selling book, Empathy and Understanding in Business, with the former FBI negotiator Chris Voss. And now moving on to Dr. Vivek Bhandari. He has decades of global experience in engineering, IT, OT, sales, general management, teaching, and consultancy. He has led the digitalization of projects globally, along with mega projects in energy and sustainability across Asia, North America, Europe, and Australia. Vivek has held leadership positions at Fortune 200 companies, as well as budding startups. His experience spans lifecycle projects, including research and development, sales, delivery, and post-delivery services. He is currently writing a book called Modern Electricity Systems, Engineering, Operations, and Policy to address human environmental needs. He utilizes his vast knowledge in electrical engineering and software development to provide Powerledger with a global edge. Wow, that's fantastic. You both have great backgrounds. And during the session, Jemma and Vivek will share insights into the purpose behind launching Powerledger's public blockchain, the integration of blockchain and artificial intelligence in energy management forecasting, and the significance of making Powerledger's vision available on the Google Cloud Marketplace, and more. So ultimately, before we begin, we welcome your questions at any point during today's presentation. So please submit them in the Q&A tab at the bottom of your Zoom screen, and we will take them after the presentation. Once again, thank you to Jemma and Vivek for joining us, and I will now hand things over for you to begin.
Beautiful. Thank you so much, Diana, for the warm welcome. Great to be here. The talk today that Vivek and I are going to do is about accelerating the energy transition. We're going to talk about Powerledger's applications and also our blockchain as well. So I just thought I'll start off by talking about the blockchain. And in July of 2023, we made our blockchain public. And we've actually had 4 iterations of blockchain since we set up the company. The first one was a fork of Bitcoin. And then we moved to a private consortium chain using Ethereum, which we used for, from until 2023. But I think with Ethereum, we found there were a lot of issues with scale, and we weren't that comfortable with the solutions, which were effectively, layer 2s connecting other blockchains to the Ethereum chain to give it more throughput. And we thought that brought like a range of other issues. We experimented with the Quorum blockchain and looked at all of the other protocols, and we decided that the Solana blockchain was really a really good technology, which was most fit for purpose for the energy use case, which has a lot of throughput by virtue of kilowatts of energy coming from smart meters and whatnot. And so we did a hard fork or a clone of the Solana blockchain, and we ran it as a private consortium chain from the beginning of 2022, until July of 2023 when we made it public. So we took the Solana blockchain, we further adapted it for the energy use case while it was a private consortium chain. And once we were satisfied with that, we made it public. And the difference is, like on Ethereum, it would process around 10 to 15 transactions per second, whereas Solana can process up to, or even more than 50,000 transactions per second. So it's really night and day. It's also very energy efficient, which is important being for an energy use case. And it's also low cost as well, which is important too, because you don't want the transaction fees of using the blockchain to be too onerous and prevent adoption as well. So that's a really exciting part of our journey. I guess we're in more experimental mode in terms of the types of blockchains that were most fit for purpose until now. And I think seeing the volume and the needs in the market, we're really satisfied with having moved the technology and with the Solana blockchain technology and adapting it for our own purposes. So what that means in terms of the blockchain being public is that other companies are able to use the blockchain, not just us. So we use the blockchain for our applications, for tracking electricity, trading environmental commodities. But now other companies that wanted to add a blockchain element to their product offerings in the sustainability space have a blockchain that's really fit for purpose. So that's basically why we made it public and what it makes possible and why it matters as well. And then in terms of, I mentioned trading electricity, just if you move to slide 4, the next slide. Thank you. I think just to explain what we mean by peer-to-peer trading and also the significance of the amount of transactions that can be produced. So if you have a small amount of people trading peer-to-peer, that can create a lot of transactions. But if you have this example, which we've got here, which is 10,000 households, where just a modest amount of 20% are trading with one another, that leads to 2 million transactions for each interval, which is 6,600 transactions per second. It's a lot. And so it's very significant. And to put in perspective how many transactions are used in different use cases, just to illustrate, Visa, for example, the Visa network globally processes 30,000 transactions per second. But when you create peer-to-peer small microtransactions, you really need a blockchain that's powerful and that can produce a lot of throughput. So that's in terms of why you need a high performance blockchain. And then in terms of our blockchain, since we launched it and made it public, it's gotten quite a lot of recognition. The Global Protocol Report, which was released just a few weeks ago, features the top protocols globally, and 42 of those are layer 1s and 8 of those are layer 2 projects. And a layer 2 is a blockchain that connects to a layer 1 blockchain to add security or to add throughput it's effectively to kind of or add more decentralization depending on how the blockchain operates. But essentially, it's to kind of address some of the deficiencies that might exist in the layer one. And in terms of different types of blockchain, many of you will be familiar with the Bitcoin blockchain, which is proof of work, which is very energy hungry, whereas a lot of blockchains now are opting for a proof of stake model. And this is actually very much more energy efficient. And both the Ethereum blockchain transition to proof of stake, and also Solana and our clone of that, the Powerledger blockchain, is also a proof of stake protocol. And so that's able to achieve sustainability whilst also maintaining decentralization. And more than half of the top 50 protocols today rely on some kind of proof of stake mechanism. And this also leads to more throughput and also dramatically less electricity consumption. So in terms of, really wouldn't work for us to have a blockchain that is, energy hungry, that, uses a lot of energy. And I think particularly given the attention that's on blockchain, sometimes rightly and wrongly, it's important to have a blockchain that is actually really fit for purpose. And then in terms of our use cases, I just wanted to talk some of those through with you before I hand over to Vivek. So firstly, I just want to talk to you about different use cases for blockchain and energy. So the first one is putting data on the blockchain, and that can be to track the provenance of data so that you can see where it originated from and validate that. So for example, a solar farm using smart meter data from the generation asset to record where the energy was generated, what type, etc., who bought it. So the buyer will also have a smart meter, so you can record all of that data. And that can also be used for many other purposes to make claims. Like, for example, if a company is saying they're using renewable energy, they can use that information to validate claims made in their sustainability reporting, or for portfolio management purposes. So then they can see how they're tracking. They might be at 70% renewable energy and they want to get to 100, or they might want to start to get 24/7 renewable energy. So that the data layer, I think, unlocks a whole range of potential. I think using the programmability on the blockchain plus the data, I think that's where you can start to get a lot of the real exciting and innovative opportunities that you couldn't get from using a regular database. But I'd say the data layer is pretty fundamental in the first place, and it can record everything from type, time, place in terms of generation assets. It can also record information like the price of energy, or it can create a record of a carbon credit or a renewable energy certificate using a token standard. And that information could say, oh, this carbon credit came from this particular asset. It was part of a vintage of this many, and it's had 3 different owners. So a lot of information can be embedded in the blockchain as well when you start to use programmability. But in the first instance, the basic information provides the potential and opportunity for that to take place. In terms of our applications, so that is one, in making the blockchain public, third-party applications that have a sustainability use case for software that want to add a blockchain element can put their data on the blockchain. And that can provide security around provenance of data and unlock a lot of potential. In terms of our applications that use our public blockchain, the Powerledger blockchain, there's peer-to-peer trading and secondary markets for peer-to-peer trade, for PPAs, pardon me. So let me explain that. So that is like a household and another household trading energy peer-to-peer, or business trading with another business, or a business and a household trading with each other. And I'll give you a couple of illustrative examples of that. So in Austria, we're working with a large utility there with an energy communities peer-to-peer trading solution. So businesses and community groups can trade energy with each other or share and give energy to their nearest and dearest. In Thailand, we've got a peer-to-peer trading project there, which is a secondary market for PPAs. So there's schools, hospitals, shopping centres, apartment buildings that have solar. They don't consume all of the solar on their roof, so they sell their surplus solar to others within the group, and that's effectively a secondary market for the power purchase agreement. So the building will have a power purchase agreement for the solar on the roof, If they don't sell it all, they can sell the rest of it peer-to-peer, which is effectively a secondary market for the PPA. And then we've also got carbon credits and renewable energy certificate trading. So that a renewable energy certificate is 1 megawatt hour of renewable power. And you can actually separate 1 megawatt of energy with the attribute of the renewable energy. And what happens is companies can buy energy from the grid that may not be renewable, and then buy certificates commensurate with that volume of energy. So say you consume 10 megawatts of power, they can buy 10 renewable energy certificates, and then they can legally and validly say that we're 100% renewable. They would need to retire those certificates. So that's what it is, a renewable certificate. And a carbon credit is typically measurement of 1 tonne of abatement of carbon emissions. And that could be from anything from, soil carbon, forestry carbon, energy efficiency projects, carbon capture projects. So there's a lot of different ways you can generate a carbon credit. And there's different types of markets, both for RECs and carbon credits. You've got voluntary markets and compliance markets. So compliance is where a government or a state sets a particular target, and any polluters or consumers of energy are required to purchase a certain amount of carbon credits or renewable energy certificates. And then the voluntary market is where companies have voluntarily set a standard for themselves. So, for example, they might say, we want to be 100% renewable, or we want to be 24/7 renewable, or we want to be carbon neutral or carbon net zero. And then they can purchase carbon credits and renewable energy certificates to be able to do that, in addition to, for example, doing their own energy efficiency projects or installing their own energy on site, or purchasing PPAs or power purchase agreements. So buying carbon credits and renewable energy certificates is very fraught and complicated. The market is it's difficult to find them. It's difficult to find prices. And so we've developed a marketplace that seamlessly integrates price transparency, physically settling, i.e. getting the certificate, and financially settling, paying for the certificate, all into one application. And we're offering that in the US right now for renewable energy certificates. And we're working on that right now in India for carbon credits. And then in terms of EVs and loyalty, this is basically looking at energy that has been, where the energy has come from, so that people know they're charging their car from renewable sources. And you can create basically tokens around that they can redeem against the energy that's being used to charge their car. And this can be part of a loyalty program that utilities offer their customers as well. So, for example, they might have a house with rooftop solar. They're selling the solar back. They get a certificate. Then they can redeem that certificate when they charge their car at a charging station in the same city. So there's quite a lot of ways that you can create new ways of engagement with customers. And then other use cases that we see emerging is around hydrogen, because there's different ways you can make hydrogen from nuclear power, coal, gas, renewables, but you can't distinguish that from like a ton of or a kilogram of hydrogen. So you need a certificate that shows the energy that was used in the production of a particular unit, and those certificates may be able to be traded as well. And so our trading and tracking platform provides the potential to do the measurement, reporting, and verification needed to get the certificates issued in the first place, which is an additional source of income stream for hydrogen producers that can be monetized. And at the very leading edge of the market, the other thing that we see a lot of is a lot of interest around, particularly around tech companies, is 24/7 carbon-free energy tracking. This is where they don't want to just be 100% renewable annually. They want to actually look at each site they've got around the world and make sure there's renewable energy actually being delivered to that site 24 hours a day. So I think this is, I'd say that the most kind of innovative end of different ways of getting to innovation around renewable energy. So with that, just to give you a bit of a sense of the different products and the different use cases and different applications, I'll hand over to Vivek now, who will speak about AI.
Thanks, Emma. So just to make sure that everybody's gotten this. Think of it, this blockchain layer, it's like a Swiss knife, and whatever Jemma described are those elements coming out of the Swiss knife. So you want to create a loyalty program, you want to track credits, you want to resell your electricity, you want to gift. These are so beautiful use cases where trade your electricity and get paid in beer, or trade your electricity and donate it to somebody. Write the data in the blockchain and create some metrics around the data. So with all of these, blockchain provides trust, transparency, all the good things of blockchain that we know, high-speed throughput transactions, and so on. Now, with this in mind, blockchain, when combined with AI, it has a compounding effect. And AI, I'm using more generically right now. I'll come into some models of AI and how we have used it or how we are envisioning to use it, like both of these. And by that, what I mean is, in terms of strategy, it's not 1 + 1 = 2, it's 1 + 1 = 3. So it has a compounding effect. AI by itself is not new. You can see the traces of AI, several decades ago, even in ancient times, where philosophically people were talking about thinkable, teachable machines. But the modern AI in the 1950s and 60s in Dartmouth, you can correlate and root back to the conferences that were happening. And now AI has gotten more interesting, and primarily all of you in the call would know about generator models, large language models like GPT, and it has taken by storm. And we have been working in AI, and now that we've got this fundamental data layer, the bigger circle in Jemma's presentation, the data layer where all the data could remain in the blockchain and the use cases on top. So, and in all of these applications, including in the data layer, why don't we use the AI? And that kind of drove into us looking at AI. But before we go there, like why AI and why blockchain? And taking a step back, when you take this step back and see, traditionally AI, whether it's a large language model, whether it's a neural network type model, you've got this input coming in, all your neurons get connected, and then you've got this output. But what is here? Black box. When I type something to ChatGPT give me an outline of a presentation, it just spits out something. But what data was it trained on? Like, why did it say what it said? If had I trained it on something else, would it say something different? Did it understand my thing properly? It's pretty much a black box. And though, like recent surveys, they say like 70-80% of the top thinkers and the top organizations see a convergence of blockchain and AI. AI typically has been treated as a black box, and that's why there is a good synergy between blockchain, because blockchain provides that transparency. If I want to limit my data, and in case of energy, say my generation data from my rooftop, my meter number, my usage profile, my personal data, I can limit it. I can limit it and I can expose it to whoever I want to expose. The generalized model can be trained in any anonymous data, but once it is being adopted to me, once there is an inference being drawn on me, I don't want that data to go out to public. I can limit that. And what data is the AI being trained? If you put it in blockchain, it's all public. You can see what data was used to train, what was filtered and what was unfiltered. What was allowed to happen and what was given more probabilities versus what was given less probabilities. So you can see all of that. And this black box problem, all of a sudden, that was due to the kind of a closed nature of AI and AI models, is all of a sudden now transparent. A good example of AI in our use case, we launched this pretty heavy name, hybrid weighted energy forecasting algorithm. So where can we use AI in the energy system? And using the examples where in the energy sector where blockchain is being used. So take an example of peer-to-peer energy trading. So when you are trading a CNI trading with another CNI, it's excess or it's just sharing because it has a solar farm 100 kilometers away and it wants to buy from that versus the other. So when it's doing that, when there is a buy and sell happening between these entities, you need to know what your generation will look like. You need to know what your demand would look like. Because if you don't know what your generation and demand is, how would you do the matchmaking and how would you put a bid and how would you do anything by looking ahead? So what we did here is we created a look ahead algorithm where it looks at a lot of things aggregated as past history and learns from the history, and you can assign weight on how much you want to lean this algorithm towards history versus towards present. So there's this weighted name there. And then it forecasts your generation, it forecasts your demand so that you can put a bid out there to buy and sell your energy. And depending on the volume, you may be a residential user where this just runs on the background and you don't bother. You just put a price and fire and forget. Or you may be a large customer who wants to sell off tens of megawatts in a secondary market. So then you may want to tweak this and actually refine this and use it. So, but now, what is this weight and where is it learning from? It's from the data in the blockchain. So that's the beauty of the blockchain, that everything becomes transparent. Another example is we've got a platform called Vision. So it's used for tracking and tracing. And one of the use cases in Jemma's slide, one of the last ones was for 24/7 tracking. So a lot of companies, lots of organizations around the world are saying that, it's not renewable enough to buy renewableness at the end of the year by calculating whatever I did for the entire year. So it's not enough. And if you want to be renewable, you need to be renewable at that place at that time. So right now I'm in Perth, it's 10:30 in Perth. If I'm consuming, I better consume from a renewable locally here if I want to claim that I'm renewable. And better that renewable be generating at the same time. So probably the only thing that can generate is some geothermal, if you consider that to be a renewable. So matching that 24/7, and when you have that 24/7 carbon matching, and you could do it with this Vision tool, which by the way is available in Google Marketplace to download, a lot of use cases of AI can be created. So imagine this workflow where you have all these meters, you have all your scope 1, 2, 3 emissions, either self-reported through PDFs, through meters. All of this data comes in, the data resides in the blockchain, and then you're creating this transparency. And when you are creating this transparency, what you can do is the readings come in. And when the readings are coming in, you could do a forecast, like the forecast of the hybrid weighted algorithm. You can forecast if there is a missing reading. You could forecast your scope 1 and 2 based on the answers that were previously provided. You could forecast based on a lot of different parameters that are there. So that's a very efficient and very good use of AI, where you can gain additional value in your 24/7 reporting. And using this AI-based estimation, then what you do is your data is pretty transparent. It's in the blockchain. You go to the next one when you need to report. So wouldn't it be amazing where you would just go to the algorithm and say like, hey, can you generate me a report for so-and-so? Enter. The data is there in the blockchain. AI goes, it knows how to format, it knows everything. It just collects all the information and your report is there. In the same way, actually, my daughter uses AI these days. She writes whatever she wants to write and goes to the AI and says, hey, make a song out of it. Same thing. Your data is there. That's the data that's been fed in. Based on this data, format me a beautiful report that complies with this reporting standard. And AI does that job for you. So instead of creating a heavy duty algorithms by collecting data and creating PDFs. It's very simple. It's pre-learned, pre-trained model, and then it works on your AI. And then now you have this report there. What you could also do is you could do sort of sentiment analysis. Microsoft committed for 24/7 renewables, and they're not doing it, and people are actually tweeting about it. People are saying all the negatives. So the sentiment is negative about the sustainability of Microsoft or their endeavors, sustainability endeavors. So you can run AI tools to get to do analysis and say, like, there is this negative sentiment happening, better act, do something, and prepare all these organizations in advance. And when you are tracking these sustainability projects, you plan and you track using AI. So it's just limitless. Imagine, like, another use case you can imagine is, I've got my laptop in front of me, I've got a printer. Each of these are capable of having bots, AI bots. I imagine a future where all the data is written in a blockchain, all these bots that are residing in my laptop, in my printer, in the bulb up, all of they look ahead, they book themselves in the future with the time slots, and they participate in the market. They know my preference that I need hot or cold. They turn it on and off automatically. They know that when I'm not I want to sell my electricity to my neighbor. It just does it automatically. It just becomes seamless. It's like the operating system of today, where you don't even think about operating system. What you just think about is the applications that are built on the operating system. So in this future, the data is in blockchain, the decisions are taken, and the decisions are augmented by the AI, and the reports are generated by the AI. You're given more analysis by the AI, and this is the future that we are headed to. And we at Powerledger are pretty much aligned with this future. If you want to, later learn a bit more about blockchain AI, feel free to reach out to me. Feel free to reach out to anyone here. Ask your questions. And there is an upcoming event. We are launching another product, XGrid 2.0. So we have been learning on peer-to-peer, and we've been calling it XGrid 1.0. So we are transforming it to 2.0, and so stay tuned on that. And this 2.0 would use all the tools of AI that I've described, using our Powerledger public blockchain. And we are headed for the future that I just described. And let's take the questions.
All right. Thank you so much to Jemma and Vivek once again for a very thorough and engaging presentation about accelerating the energy transition. I'm Diana again. I'm head of research and sustainability at GBBC, and I'm going to take questions now. We have a number already from the audience and a few questions that we received ahead of time as well. So I would like to start with saying, tell us a little bit more, Jemma and Vivek, as you mentioned your journey about iterating and managing a public blockchain, what factors did you consider to decide what blockchain to build on, and how has that played out? You mentioned the Solana blockchain, you mentioned the importance of the energy efficiency and obviously the scalability aspect, but what led into, if you have any more details into that decision?
Yeah,
Vivek,
sure.
did you want to build on my earlier comments?
Yeah, sure. So, that example that Jemma had, and you've got a nice decagon or logo there, right? So
Okay.
you can see all the nodes and all the interactions there. So if you have 10 participants, so 10 people trading electricity amongst one another, you can have 45 different transactions. So you selling with me selling with Jemma selling with the audience selling with you, and so on, right? So So, and now you add one more number, and if you just take it to like a couple of thousands, it just becomes millions of transactions. And when we looked into, we had Ethereum and we had private consortium. So when we had Ethereum, the number of transactions are in tens. No way this will be able to handle the tens of thousands of transactions or millions of transactions per second in future that we are getting. So being ready for the future. And if you think of it as, the Moore's curve, and in Moore's curve, it was said that the hardware will plateau. It doesn't plateau, right? So we're seeing that the chip gets smaller and smaller. Now it's quadrillion transistors in every 2 years, and it'll be 2 quadrillion in another 2 years. So the hardware will always improve. What we need a software that can be scalable. So we are preparing for that future where there are these transactions, and we don't need to go and change again. And your question was public and private consortium. Blockchain, I'm a firm believer that it's by its nature public. Mm-hmm. And you don't want to control that blockchain. If you have a belief, you can bootstrap it. You can have you can kind of give it a push in the beginning, but ultimately it's the public who are going to control it. So it was a very easy choice to make it public.
Yeah, then so the network.
Correct. And then the third one is price. So it needs to be affordable. You don't want, you're talking about, so in Minnesota, when I was living in Minnesota, electricity was 10 cents. So in Australia, it could be 30 cents, right? So it just kind of goes between 10 cents and 30 cents, I would imagine. And if you charge at some point, say 0.2 ETH, mm-hmm. then nobody will write there, right? So you're talking about 1 kilowatt is in cents, and you're paying a transaction fee of 10 folds higher. So we wanted something that will give high throughput, low cost, public, and it's very simple. So fork out Solana and make your tweaks.
Yeah, thank you so much, Vivek. I just wanted to add another thing to illustrate the point that Vivek made around the volume of trades. I mentioned a couple of examples before about in France and Austria and Thailand, but we're also working in India, which is a very large market, with more than 1 billion people living there. But one state that we did a peer-to-peer project in is called Uttar Pradesh. And we did a demonstration project for peer-to-peer trading of energy. And the regulator was very interested in this because they're lagging behind with hitting their renewables targets. And the way most countries have hit those targets is using subsidies with feed-in tariffs. But what that does is pushes up the price of electricity, and they didn't want to do that. It's a low-income state. They can't afford to pay more for electricity. And so what they saw possible with peer-to-peer trading was a market mechanism to incentivize the growth of renewables without subsidy. So they changed the regulation to allow this. They announced this in April of last year, and they actually wrote in the regulation, blockchain peer-to-peer trading. Now, in Uttar Pradesh, there's 225 million people living there. And that's, the amount of trades that could potentially happen if even just, 20% of the people living there are trading energy with each other is, voluminous. Similarly, last week, a neighboring state, Karnataka, they've only got 65 million people living there. They put out draft regulation to also allow peer-to-peer trading across the state. And so the need for a highly performant blockchain really came into sharp focus for us when we started to look at the potential scale that these projects could deliver over time, and that we needed to be ready and prepared. Otherwise, clients would not be willing to go on the journey with us.
Yes, Jemma, and you literally just answered my next question. You had mentioned so many use cases for blockchain in energy, and at the bottom of your slide with the use cases, there was a QR code. I actually went to it and it linked to a report, and you mentioned India as one example. You had a whole section on that. So unless you elaborated on, if you want to add anything else on the implementation of India that you feature in the report, go ahead. Otherwise, I'll move to the next question. But it must have been a very exciting journey.
Yeah, I mean, I think it was, we set up Powerledger 8 years ago. It's 8 years old in May, and it was a hugely significant, moment because, pioneering something that is, a new market model, is hard work, and to get those kinds of that proof points is really very satisfying and reassuring as well. And to see there's 5 or 6 other states in India which are similarly looking to change their regulation. And the other exciting thing about India is, well, one, the utility, it's one utility, covers a lot of people. So the scale potential is significant. Whereas, like, I live in Switzerland and there's 9 million people that live here, but there's 600 utilities because each little village might have its own utility. So from a coverage perspective, it's far more complicated. So I think India, it has other challenges, but in terms of scale potential, it really ticks the box. But the other thing that makes India interesting is that they're a large producing and exporting nation to Europe. And Europe has created this regulation called the Carbon Border Abatement Mechanism, or CBAM, which by 2026 will mean that companies that export products into the EU need to actually have either demonstrate the embodied carbon in the products, or otherwise purchase abatement. And so it's going to be increasingly important for these nations to track electricity as well. So I think that India is exciting for us from a tracking electricity perspective. And then the other piece is carbon credits. We're seeing a lot of interest around carbon credits from the voluntary and the compliance side of things. And as countries really gear up their focus for net zero targets and the climate accord targets, that's going to come into sharper focus too.
Right. Are you looking into any other regions as promising, or potential countries as promising, especially the Global South, the role of the Global South with respect to carbon credits and the carbon markets? Love to hear your perspective.
Yes, we are engaging in conversations in Southeast Asia around carbon credits. I'd say, it will be different in terms of where the projects come from, like the carbon credits originate from, and then where the buyers are. And then I think distinct from renewable energy certificates, which are generated in one country and purchased in the same country, carbon credits can be generated anywhere and purchased somewhere else. And so I think that makes it a particularly perfect use case for tokenization of carbon credits, for ease, for removal of issues around duplication. It doesn't solve all of the issues that can be found in the carbon space, but I think having a tokenized carbon credit does solve a whole multitude of problems, from like Web 2 solutions for carbon credits, and you will see a lot coming from the Global South.
Excellent. Now moving on to the next question, which we received earlier on. Does the Powerledger platform integrate with existing energy infrastructure, and what are the main challenges in this integration?
Take that. Yeah, it does. So generally with the energy infrastructure, what we need is, if it is peer-to-peer trading, is meter readings. And meter readings generally can be connected using some sort of a RESTful means. So we've got RESTful APIs that our customers hit, or they have RESTful APIs that we hit, and we collect that information. The challenge early on was, these meter reads will take time, so they're not real time. So, once I turn on my light here, it'll not send a read. So it happens at the latest once every day. And then it goes for a processing that takes around 12 hours. And then it hits the REST API and then our API. And still, if there are some issues, then we'll need to fill in the blanks and do all of that. Then 2 days after, it can come again, because an updated reading has come through. So you should have the workflows clearly defined such that you account for that. And then again, you know what? After 10 days, the reading can come again because it has been rectified again. In month number 2, an actual meter reader goes there and reads it, and then it comes again. So, you have to be, your workflows should be balanced in a way that you take into account these nuances of readings. But short answer is, we connect pretty much seamlessly to these systems, inbound and both outbound. So outbound is when we are, say, sending a control signal to a battery. And again, in that case, standard protocols already exist. So if you follow the standard protocols, it's a matter of mapping it to that actual use case.
Wonderful. And how does Powerledger navigate the regulatory environment across different countries to promote blockchain in the energy sector? You've alluded to it a little bit, but please unpack this because it's very important.
Yeah, maybe I can start from India, stepping on what Jemma just said. So the regulator, we had conversations with the regulator of India and Uttar Pradesh as an example, and they liked the power of blockchain, and it was them driving rather than anything else. So if you have regulators who are forward-looking and who see the future, it's relatively easy. And once you have one regulation change, there are lots of I also want to do it. Am I foremost? Am I missing something? And then actually they might be missing something. And then you see another state coming up and saying like, oh, I should issue this and I should do this. And then there is another state, and it just ripples. So, but initially it's challenging. It starts for us. It's almost always been do a pilot, do a really hard work, produce beautiful reports, make those regulatory submissions, and then don't hear anything for 2 years. So, but once it starts happening, it starts happening.
Great. Now, as we move on to something that has to do with the governance, could you first explain a little bit more the role and the importance of validators? And then what is the value proposition to validators, and why would I not just sell my power back to the retailers?
You see a lot of things are happening in right now, so you better want to hold it. Jemma, you want to take it?
Yeah, so if you have a proof of work blockchain, you're really solving like a complex mathematical problem, an algorithm, and that uses electricity. And so it's the amount of energy that is used, and then the actual hardware that's used to, to solve the problem. All of that adds up to like a lot of cost and investment. And then the reward for that investment is getting like a Bitcoin or, another proof of work token or cryptocurrency. Whereas proof of stake, because I think your question, Diana, was multi-part. The first thing, what's the role of validators? And then why wouldn't I sell my energy back to the utility was the second question. So I'll answer the first part first. And then for the role of validators comes into question or comes into need when you have proof of stake. So that's actually where the blockchain is not maintained by miners, but instead maintained by different companies or individuals that maintain hardware that maintains the records on the ledger. And they provide a service, which is actually maintaining the records. And then how it works is they normally have a certain amount of a token that they put up as a form of collateral, which is called a stake. And then they get paid a fee for maintaining that node. And with a certain uptime, they get paid a reward or a fee. And if they fail to do that, in some circumstances, they might actually lose some of their collateral, or it might be at risk, or in other places, times that they just might not get a reward, and that's the penalty. So if you have a proof, and why do you have proof of stake? Well, it actually doesn't use as much energy. So you're really using a collateral mechanism and a fee for service mechanism to maintain your blockchain. So it's just far more energy efficient than an ever increasingly complex algorithm, which is the case in proof of work. So I think the role of validators.
Just to show,
yes.
Just to show, this is actual validator of our blockchain. Like this is a simple HP computer, and this is an actual validator sitting beside me.
Exactly. Yeah. Case in point. Thank you, Vivek. So validators are extremely important for proof of stake blockchains, which are energy efficient. and it's a a very useful system for maintaining the data on the chain. And the second question is, why wouldn't I sell my electricity back to the utility? Well, the answer to that is most people that have rooftop solar, they're surplus. That's exactly what's happening. And the model to do that up until now has largely been a feed-in tariff, a subsidised feed-in tariff, which was very expensive for governments and actually resulted in it was basically a centralized price signal that encouraged indiscriminate growth of renewables, often far away from where it's needed. And as a result of that, the grid had to build all sorts of infrastructure to bring electricity to where it was needed, like poles and wires. And you can see a phenomena now in all the countries around the world that have a high amount of variable renewable energy, so solar and wind. They have the highest electricity prices in the world. Germany, Denmark, Australia, and it's a broken model. The centralized model for growing renewable energy through subsidized feed-in tariffs, i.e. selling your energy back to the utility with a subsidy, has caused electricity prices to skyrocket, caused grid instability as well. So it's not a great model. The model that we see as being more viable, both for the consumers and also for the grid, is what we call local energy markets. And that's where you trade energy locally, so within your suburb or area. And so what happens is your energy gets exported but consumed locally. And so it doesn't need the upgrading of the poles and wires that I mentioned earlier, which is very, very costly. And the reason why would I want to do that, to answer your question specifically? Well, it could be that you are given a price incentive from the network to do that, because the alternative is they have to upgrade the grid. So it could be they could give you a discount to trade the energy. So Deanna might live on my street. She could have batteries. I have solar. I export my surplus solar. She stores it in her battery. I purchase it from her at night. And why would Deanna want to do that? Well, the reason is because she's getting paid money every time I use her battery, and she can pay off her battery. Instead of it taking 11 years to pay it back, she could pay it back in 6 years. Yeah. And so that's compelling. And then for me, I know I'm getting renewable energy and local energy, and that's appealing to me as well. So that's part of the value proposition. The other piece is that it could be that I just want to donate my solar to my local community group or my school or my grandma. And that's something people want to share and donate their energy to their nearest and dearest. So it's not always about making money out of the energy or selling it back to the utility at a particular price. And now what we're seeing is that the subsidies of the feed-in tariffs have come down. So there's not actually this huge economic incentive causing perverse outcomes occurring in most places. But so the feed-in tariff is more akin to what the wholesale price of electricity is. But again, because it's fixed, it doesn't always reflect the actual circumstances of the grid. So it's still causing problems on the grid. And so the local energy market concept is basically based around the idea that the price of energy changes depending on the local circumstances. So you have a more dynamic nodal pricing of energy, which we think is far more fit for purpose for distributed and decentralized energy.
Yeah, this could be a game changer. I remember we co-authored and we worked on a report on decentralized energy systems last year, where you worked a lot on local energy markets and the concept of renewable energy being more variable, and it's just fascinating to see your progress and how you're building this product and these solutions to really make them real, because we haven't had that concept in real life, and now we're making it real for everyday individuals. And I'm just so impressed. Maybe one more, we have time for one, maybe two more questions, but the next one in line is the Powerledger blockchain corporate owned, or is the ownership decentralized? Can you discuss the governance, as in what is the process of adding enhancements or modifying the rules?
Yeah, so Vivek, did you want to answer that?
No, go ahead.
Well, as a public blockchain, it isn't owned by anybody. Powerledger does have a lot of the nodes right now, but over time,
we will relinquish those once we've, you know, gotten comfortable with it all being tickety-boo as a public chain. And so then, yeah, there will be different rules and programs in place for upgrading, you know, and I think there's quite a lot of information on that for people that want to know more on our website. But it will be like any public protocol, open source and not owned by anyone.
Great. And maybe you can do the next one. What are your thoughts on blockchain transactive energy, BCTE?
I'm assuming this is IEEE BCTE working group where they were looking at blockchain transactive energy. We have not actually participated in this working group. I am a senior member in IEEE, but we have not. We do participate in other forums, like there is one from University College London called Go P2P, a very similar objective. SIGRI, almost every other year they've got working groups on blockchain and transactive energy. We do participate with GBBC here. This one we follow, but we are not participating at the moment.
Great. And then what are the tangible benefits for consumers who participate in the energy market using Powerledger's platform? You already alluded to several, but if there's anything you want to add, please go on.
I think supporting local energy projects, you know, paying off your investment in like battery storage faster, in the case of a local energy market, being able to share energy with the people most important to you, your nearest and dearest, creating energy communities, local energy communities, supporting local economic development, driving greater adoption of renewable energy.
Fantastic. I wish we had more time. Unfortunately, we're out of time. To the participants, I'm sure you can reach out to Dr. Vivek and Dr. Jemma. And once again, thank you so much to Vivek and Jemma for this presentation and for your time and answering the questions in the way that you did. We look forward to learning more about Powerledger's progress in this amazing journey. A recording of this presentation will be circulated to all those who registered and also shared publicly on GBBC's YouTube channel. Thank you to everyone and have a great day.
Thank you.
Thank you. Bye.